This video is to introduce how to solve absolute value equations. Considering the first example, we're looking for when the absolute value of x is equal to 6. Before we talk about the solutions for this, let's talk about the definition of absolute value. Absolute value is the distance to a number from the number 0 on a number line. So on a number line, we have positive numbers that go to the right and negative numbers that go to the left. So if we're looking for which numbers are 6 units away from 0, then we count from 0, 1, 2, 3, 4, 5, 6. And we see that x equals 6 is 6 units away from 0. So this is one of our solutions to example 1. We also see that 1, 2, 3, 4, 5, 6, x equals negative 6 is also 6 units away from 0. So even though I'm going in the negative direction, the distance from 0 is still a positive 6. So we have two answers. X equals 6 and x equals negative 6 are both 6 units away from 0 on the number line. So let's consider this example. We're looking for where the absolute value of x is equal to 4. So beginning at 0, counting 4 units to the right, 1, 2, 3, 4, we see that x equals 4 is 4 units away from 0. Going to the left, 1, 2, 3, 4, we also see that x equals negative 4 is 4 units away from the number 0. So again, we have two solutions, x equals 4 and x equals negative 4. How do we reach these solutions without using a number line? So in both example 1 and example 2, we saw that we had two cases. Case 1, the solution side is positive, and in case 2, the solution side was made negative. So each time we need to solve an absolute value equation, we need to make two cases. The first case is when the solution side is positive, and the second case is when the solution side is negative. Another way to look at it is considering the absolute value bars as jail bars. And in order to find the solutions for x, you have to break x out of jail. So, let's practice a jailbreak. I have absolute value bars, so I need two cases. One where x equals the positive solution of 4, and one where x equals the negative solution of 4. Now let's consider when is the absolute value of x equal to negative 4? Why doesn't this equation make sense? If we think back to the definition, the absolute value of a number is the distance that number is away from 0 on a number line. Well, distance is never measured negatively. Distance is always a positive number, a positive measurement. So it doesn't make sense for us to have a distance that is negative. So in this case, if we're looking for where the absolute value of x is equal to negative 4, it doesn't make sense because it's a negative distance, so there are no solutions for this problem. Example 4. We're looking for where the absolute value of x plus 2 is equal to 4. So I have absolute value equal to a positive distance, which makes sense. So I need a jailbreak. I need to set up my two cases. X plus 2 is equal to 4, and x plus 2 is equal to negative 4. Notice the only sign that I changed was on the solution side. This is always the case. You always change the side on the solution side when you're making your cases. So from here, I have a little bit of extra work to do. I need to solve both of these equations for x. In order to do that, I need to subtract 2 from both sides, which on this left case, we have x equals 2. I need to do the same thing on the case on the right. X equals negative 6. So I think I have my two answers, x equals 2 and x equals negative 6. It is always possible to check your solutions by plugging them back into the original absolute value equation. So if I take 2, plug it back in for x, I would see the absolute value of 2 plus 2 is equal to 4. 2 plus 2 is 4. And the absolute value of 4 is 4. So the solution of x equals 2 checks. Checking negative 6. Negative 6 plus 2 is negative 4. After taking the absolute value of 4, we see that our solution of x equals negative 6 also checks. Let's try this example 5. I see that I've got absolute value equal to a positive number, so I have the green light for my two cases for my jailbreak. 3x minus 2 is equal to 4, and 3x minus 2 is equal to negative 4. From here, I have two equations I need to solve for x. I begin this process by adding 2 to both sides, so 3x equals 6. I need to do the same to this equation also, so 3x equals negative 2. And to finish solving, I need to divide both equations on both sides by 3, which gives me a solution of x equals 2 and x equals negative 2/3. Both of these solutions can be checked by substituting them back into the original problem one at a time. An important side note for working problems such as example 6, before making two cases, you must isolate everything in absolute value. So what that means is you need to get the absolute value of x by itself on the left-hand side before setting up your two cases. So going along with the jailbreak analogy, you have to get rid of all of the prison guards before you can do a jailbreak. So we need to subtract the 4 in order to get rid of the 4 guarding the jail. And we also need to divide the 3. So now we have the absolute value of x is equal to 3. And now the absolute value is isolated on the left-hand side. So we are ready for a jailbreak. We're going to set up our two cases. X equals positive 3 and x equals negative 3. Let's try our next example. Example 7. We have prison guards. We need to isolate everything in absolute value first. The absolute value of 5x minus 1 needs to be by itself on the left-hand side before we set up our two cases. So we begin this process by subtracting 10 from both sides. So 3 times the absolute value of 5x minus 1 is equal to negative 9. From here, we'll divide both sides by 3. The absolute value of 5x minus 1 is equal to negative 3. So we have the absolute value bars isolated on the left-hand side, but we pause for a moment and consider what we have. We're back to a negative number. And remember, absolute value is the distance a number is away from 0 on the number line, and distance can't be negative. So since I have the absolute value of 5x minus 1 equal to a negative 3, there are no solutions to this problem. Our final example is just like example 7 with one exception. There is a negative in front of 3 this time. So let's see how that changes our result. We begin the same way. We subtract 10 from both sides. Negative 3 times the absolute value of 5x minus 1 equals negative 9. So I have equal to negative 9. However, when I divide off the negative 3, the absolute value of 5x minus 1 is now equal to positive 3. So I pause, I look, yes, we have a positive number equal to what is an absolute value. So we're ready for our two cases, ready for our jailbreak. 5x minus 1 is equal to 3, and 5x minus 1 is equal to negative 3. To solve these two equations, we need to begin by adding 1 to both sides. When we add 1 to 3, we get 4. And when we add 1 to negative 3, we get negative 2. Our last step in solving, we need to divide both sides by 5 on both equations. So our two solutions, x equals 4/5 and x equals negative 2/5. And again, both of these solutions can be checked by substituting them in one at a time back into your original problem.